Welcome to SolTouch. In this series, we're gonna go through how to create a Solidity environment and how to create Solidity contracts. And we're gonna go through the most common and most requested types of contracts in the blockchain market. We're gonna start by setting up the environment for Solidity development, and we're gonna go on with creating the most requested contracts like ERC20, staking contracts, and the different properties of the ERC20 tokens. So stay tuned, guys, and if you enjoy and find it useful, click the subscribe button. The first step, if you want to develop in Solidity, is to create a Solidity environment. For that, you will need a couple of tools that will be very useful for you to develop your own smart contracts. We're gonna start with Truffle, which is an npm package. In order to install package, you have to run npm install Truffle and the G flag for global in order to install it globally. I already did this, so I won't run this command again. Then you will have to go to the folder in which you want to create your project and run truffle init. When it's finished, this command will generate a couple of folders and a file named truffle config. In the contracts folder, you will find the contracts that you will develop, and you will place them here in order for Truffle to know where to migrate from. With the migrations, you will tell Truffle exactly which contracts it needs to deploy on the blockchain, and here you will run your tests. So if we go to Truffle config, we'll find the file with mostly commented lines, and here is where you specify where do you want the contract to be deployed. In networks, you will have an object, a JSON, in which you will have all configurations for all the networks in which you may deploy at some point your contract. The first thing we want to do is to get linked to a blockchain. For development, I recommend you to download Ganache, which is basically a local blockchain with all the functionalities from the Ethereum network. I already downloaded Ganache for this tutorial, so I won't go and download it again. When you start Ganache, you will probably get something with quick start and some other button. If you click quick start, you'll get exactly in the screen where I'm at right now. So let's set up and deploy this migrations contract on Ganache. What we want to do now is specify in the truffle config that we want to use the development network to deploy our contract. So for that, we need a host, which is the local host that's correctly set. We need the port on which Ganache is running, and you will find that here. After you specify the port, you will need a network ID. You can find in Ganache the network ID here. So go ahead and paste it here, and there you go. You have a configuration for deploying locally. So if I go now into the terminal and write truffle migrate network equals development, here I specified the development network, so it will read the config from here, and if I click migrate, it should migrate successfully on Ganache. Don't get intimidated at first about these migrations. You might not understand from the first try what are those, but don't get intimidated by them. Simply ignore them in the first try. Okay, so our contract is deployed. We can find it at this address on our local blockchain, which is here. You can see that there's a difference here in the balance because the contract was deployed, and you can find the transactions here. I did 2 transactions here before the tutorial, so I also have these 2, but the newer ones should be here. We can identify them by transaction hash, for example. Good. This is the one. So deploying on a local blockchain isn't going to be useful for pretty much anything other than development. So in order to get into the real deal, we'll have to deploy at least on the testnet. For deploying on testnet, we will need to connect to the testnet, and for that we either run a local Ethereum node for the testnet, or we go to a provider that does this for us. Truffle works quite well with Infura, so if you go and create an Infura project, then you will be able to connect to Infura's node. So I have a project created here, but you just go ahead and create your own projects. Tutorial, it's this simple. You just have to give it a name, and then you get here into the settings, and you can choose to get an endpoint for your specific network to which you're trying to connect. I'll choose Rinkaby for this tutorial. Robston is pretty much not working when you want it to work, so I usually use Rinkaby and I had no problem with it whatsoever. So I'm just copying that link, and I will need to define another network config here, which I'll call Rinkaby. There will be a little difference between the development and Rinkaby settings, because we need a provider. So we need a wallet from which we need to deploy the contract from. So in order to specify the provider, I will need to use HD wallet provider. What this does, this is also an npm package which we need to use for this tutorial, and what this basically does is that it generates the addresses from the mnemonic phrase that you specify. I will specify it here, and I will take this mnemonic phrase from here. I'm just not going through the trouble of creating another wallet, and I simply use this wallet from Ganache. So once we've done this, also we need to uncomment this line which requires the HD wallet provider. But once we have done this, we are safe to connect to a network. We'll also need to specify the network ID, which in our case for Rinkaby it will be 4, and we need to specify, and this is an important setting, we need to specify the gas that our contract might consume, which I think it's very big for our small contract, but nevertheless it's testnet, so I'll keep it at the default value. And you will also need to specify a gas price. When you deploy on the mainnet, you have to be very careful about these settings here, because they can eat away your Ethereum if you're not careful how you do this. So be sure to always test on the testnet and see how much it costs. You can decrement this value until it throws an exception and reach an optimal amount of gas used to deploy the contract. About the gas price, this is specified in Wei, which is the smallest unit of Ethereum. You can go on gas station here, gas station ETH, and to this website and see how much gas does the mainnet consume and what's the required price in order for miners to mine your transaction. Right now it's actually really high. Good. So we have our settings done for deployment onto the testnet. I also want to specify a very useful tool, which is MetaMask. With MetaMask, you are able to see it all in your browser, to monitor your balance. You can put a wallet right here and see what happens with that wallet almost in real time. So this is just a sideline for you to know about this tool. Okay, we can go ahead and deploy this on Rinkeby and see if it works. We have an error, cannot find module truffle HD wallet provider. Of course, we have to install this with npm. So npm install, and now it will create the node modules and install our HD wallet provider so we can use it when we deploy the contract. It will take a couple of seconds. You're also probably wondering, what are we deploying right now? This is just a basic migrations contract that Truffle comes with, and it's basically something that you can test that your deployment is working. But when you'll want to create a real contract, you'll go here and create your actual contract. So new contract.sol, and here you will write your newly created smart contract. So first let's try to deploy on the testnet. Okay, and see if it works. And if it works, we're gonna write a short contract and get just a little tiny bit into how Solidity contracts should work and should be created. So everything is up to date, there is nothing to compile. When you write truffle migrate and you specify the network, if at some point truffle already migrated that contract on the network, you will get this message, because he basically tries to start from where it left. So if he doesn't find here a file which is called 2_ something, it will look at this file and say, okay, I parsed already that migration, so I won't do it again. So if you want to re-migrate from the beginning, you have to put this reset flag here. Let's see if it works. He's thinking. Okay, good. It seems to work. But we deployed on Rinkeby. Network name, development, network ID. I'm not sure if this is really deployed on Rinkeby or still on Ganache, because it says network name is development. Let's check that quickly on Google. So truffle migrate specify network. Okay, the network option, truffle migrate network live. Right, I think truffle migrate network Rinkeby. Maybe the equal sign doesn't have to go there. Yep, seems like it. Oh no, it's just a typo in my, I wrote network instead of network, so that could have been the issue. when you write something like this and you don't specify the flag properly, it deploys on default development network, and that's why this warning was popping up for me. Okay, so right now we should be good. It's a network name ring by fork, network ID 4, so we're good to go, and we're deploying on the testnet. Here you can also see a summary of the deployment with this is a dry run, so this shows the summary of the dry run, and this is the real actual deployment on the testnet, which shows the summary, which tells you how much did the transaction cost, the transaction hash, and at what address was the contract deployed. Okay, so we've done this for the simple default contract, but now we want to create something for something original that doesn't come with the truffle. So we're gonna have a new file here and call this new contract.sol for Solidity. First, we want to specify the compiler version, and for that we're gonna have to use pragma solidity and specify a version. If you get some errors at deployment, you probably also need to install the solc compiler. So I already have solc compiler installed, and it's version 0.7.4. so if I want to specify a different version in some cases, I can go here and modify the version. If you're wondering when we need to decrement, for example, the version, there might be some libraries which you really need to use in your contract deployment, and they might be a lower version of Solidity. So you'll have to go here and specify the desired version of solc compiler that you want to use. Okay, so he's crying about something. Yep, I think this was the issue. Okay, so let's go on and create our contract. So new contract is gonna be the name. I'm gonna have a variable which will be a public variable, and it will be the contract name. Also, we need a constructor. The constructor is the function which is called when you deploy the contract, and only then. You don't have to specify a visibility like this for the constructor from a certain version of Solidity on, because it's by default public. Good, so we want to pass to this contract, we want to pass the contract name, and we want to store it in this global variable that we defined before. So we need to specify memory for this variable. I won't get into details about what this means, but basically in Solidity you can have variables stored in memory, or you can have some variables in storage. For example, this one is in storage, this one is in memory. Okay, so now let's figure out how to call this constructor and how to create a new migration that deploys this specific contract on the ring by network. So I'll create a file here which I'll call to new contract. You can put whatever name you want to put here, .js. I'm gonna go ahead and copy this and put it here and just change the names. So new contract, and I will require my new contract, and I will also deploy it. The parameters for this deploy function is first of all the artifact, which is our contract, and then you have the variables that you want to pass to the constructor. In our case, our first cool contract. Actually, I can name this contract cool. I'll just leave it like this. And if you want to specify a different address of, by default, Truffle is deploying from the first address derived from your mnemonic phrase. If you want to deploy from the second address, you will have to specify it here after the constructor parameters. For now, I'll just deploy it from the default address. Okay, so here we go. I don't need a reset because I don't want Truffle to migrate again this initial migration. I wanted to go ahead and migrate only my new contract. So I won't specify a reset here. Oops, we have an unexpected token in our contract. So in truffle config we have an unexpected token. I think it's this one. I decommented more parentheses than I should have. Let's run it again and see if we fix the issue. Okay, so it's now compiling the contract. So I guess if it got to this phase, then truffle migrate is in order. It gives us a warning about not specifying the license, but we can simply ignore that as it has no impact whatsoever. Alright, so he skipped directly to the dry run of new contract.js, so he skipped the initial migration, which is good. And okay, we should have our contract deployed shortly. Now it went ahead to the actual deployment on the Rinkaby network, and it's trying to deploy with this transaction hash. It usually lasts for a little bit longer than the dry run. Okay, so we have our contract at this address, and the pretty thing is that we can use rinkaby.etherscan.io and search for it. Etherscan is really a great tool for both development and for inspecting the Ethereum network. So we found our contract already at this address, and we can see here the bytecode, which doesn't really tell us anything about the contract. But if you want your contract to be public and you want people to see the code inside it, you can go here and actually upload your source code here, and it will be public and everyone can see and confirm that this is your code. So I'll actually do that. I placed my contract here. I'm not a robot. Okay. Verify. Good. So we got the bytecode generated, and we can go here and Etherscan creates the ABI and lets us interact with the contract from this interface directly. So our contract is now deployed, and Etherscan knows our source code, and from here we can actually interact with the functions of the contract. Because I have no functions that modify the contract, I will get nothing in the write contract tab. But in the read contract, we can see all the getter functions, all the public functions that do not modify the state of the contract, and also we can monitor and see the public variables. So we can see here our first contract, it's exactly the name, the parameter that we pass to the constructor from this file here. So there we go. It's all set. We deployed our first contract on the Rinkeby network, and basically in order to deploy it on the mainnet, you have to do a very similar thing. You need to just go to Infura and select mainnet from here and copy this link and put it instead of the link we have right now in a different network. So you will write here mainnet, and you will basically copy this but replace this with the mainnet. Be careful again when you deploy on the mainnet about these parameters. Try to keep the gas price at the lower side, so something close to this number will suffice, and just take care this number is in gigaway, and this is I think in way, so it has a couple of more decimals, and try to keep the gas as low as possible. You can run some tests, or there are tools online to see how much gas you need to place, but contract deployment is very expensive when doing on the mainnet, and if you mess up some parameters, or if you mess up the gas price, you might end up spending some useless money when you don't need to. So just be careful about that side, but the rest of the process is basically the same when you want to actually deploy on the mainnet. Good, so we're pretty much done for now. We went through what truffle is, through what ganache is. We've basically done a very standard contract. I didn't get to tell you about the ABI, and I think I should do this in this episode, so let's go and look for an ABI. This is the ABI of our contract, and this is basically created by Truffle when it's compiling. This is an object, a JSON object, which specify exactly what functions and what variable your contract contains. And this will be important in the future, because when you interact with the contract with Web3 or something like Web3, you will need to have the ABI of the contract, which is basically a rough description of your contract. We went through what Infura is. So Infura, in short, is a different is a node with which you can connect to the network, and you don't have to get your local node. MetaMask is another very useful tool. We deployed our first contract, and one more thing I wanted to leave you with is a very useful library for smart contracts, and that is OpenZeppelin. OpenZeppelin has some already built, very solid and good, useful contracts that you can use in your development. It has all sorts of things from SafeMath to ERC20s and all other necessary libraries for day-to-day Solidity development. So you can go ahead and look into it. I will leave all the links in the description below, so you can find them there and download all these tools and use them to set up your Solidity environment. So that's about it for this time. Thank you, and yeah, see you next time.